Back up in 2.1 where we left off. And if you recall, we hadn't really done much but graphing yet, but we are working with vertex form of the equation. So everything we talk about today and yesterday is in that form where it's a x minus h squared plus k. The advantage of that form is the vertex is staring at us, okay? Or what we used yesterday with graphing, how far left or right, how far up or down. Now we're going to do some stuff without graphing. I think we talked about this right before the end of class, if I'm not mistaken. Or did we end right on the graph?
We ended before we started talking about it.
Okay, we didn't really talk about this yet then? Okay. So, besides vertex, okay, so vertex, HK, how far left or right, how far up or down, axis of symmetry. You guys know axis of symmetry, right? You're supposed to. It's always the first number of the vertex, right? The x-coordinate, x equals. Now, the vertex of the parabola is either going to be the maximum or the minimum of the graph. If your parabola is right side up, where is the vertex? The vertex is at the bottom and it's a minimum. If your parabola is upside down, then your vertex is at the top and it's a maximum. Okay, so we're going to talk about that. Domain. I didn't talk about this yesterday. Domain is back, but good news. It's domain about parabolas. What do we know? How far left and right does a parabola go? Infinite, right? Because it's going, as it goes up or down, it's getting wider. So domain is always negative infinity and positive infinity. And then range will be based on the max and min. So we'll work on range. I did mention you might see some 5-part questions in Savas. I haven't been in there to remember for sure, but if I have a problem set up like this here, you probably see something similar in Savas. Okay, so let's look at this. They're asking us to identify the vertex, axis of symmetry, min or max value, domain, and range of this graph. Okay, so first thing I'm going to do here is I'm going to write the form of the equation. The f of x equals a times x minus h squared plus k. Okay, that's our vertex form. And the equation, I'm going to write the equation we're using right underneath it. The equation we're using is what? 2 times x minus 3 squared plus 4. And I'm writing those right underneath each other just so we can kind of see what this graph is doing. Okay, first thing they ask us for. Let's start with the vertex. Thoughts on the vertex? You can think H and K, or I also correlate it with how far left and right does my graph go? How far up and down does my graph go? Right?
3, 4.
3, 4? Does that make sense to you guys? It's 3, 4. So right there, if we talk about H and K, now the key is you'll always use the H, you'll use opposite the sign every time, and then the K is the given. But so we can think of it as H and K. Or what does this minus 3 tell the graph to do? The minus 3 is going to tell the graph to go what? Right 3. And the plus 4 tells the graph to go up 4. Can you think like that also? If my graph has to go right 3, up 4, isn't that where my vertex is going to land? Okay, so we have our vertex. Axis of symmetry. Thoughts on axis of symmetry? X equals 3. And why is it x equals 3? It's always the first number from the vertex, yes? Always the x-coordinate. If you look up here, it says x equals h. So it's always x equals, and again, it's using that opposite sign there. Okay. So far, so good? If I have a question, ask, but I feel like this stuff relates to last chapter, right? So it's kind of review, reteaching. Now, the next piece we're asked to do is we want to know, and I guess all I can write is M right now, is it a minimum or maximum value? Hello. Where are you in your office? Okay. Bye. Kelly, Mrs. Fernando needs to see you in her office for just a couple minutes real quick. Huh? She didn't say so. Her office is, if you go down to the end of my hallway, it's right there in that back corner, the guidance office. Okay? Yeah, just go to the hallway and go right like you're going outside. She said it had to be right now. It's just like 5 minutes, so. Okay. Aliazine says minimum. Why?
Well, I assume it's a normal parabola.
Okay. And how do we know, you guys can't see him, he's sitting in the back, but he says it's a normal parabola and he draws it facing up. How do we know it's facing up? Okay. There's not a negative out front. This 2 right here, I don't really care that it's 2. I care that it is positive. And because it's a positive 2, that makes it, in our minds, a normal parabola. Since it's positive, that means our parabola is going to, it opens up. Okay, so anytime that number out front is positive, the parabola opens up. And where is the vertex? The vertex is at the bottom, thus making it a minimum. Minimum. Sorry, I'm having a spelling issue up here. Maybe it's just me that can't spell minimum, but. Now, besides stating whether it's a min or a max, it actually asks us for the minimum or maximum value. So we know it's a minimum here, and we want to actually know the value. Actually, I don't need to write the word value, I guess. Minimum or maximum value. That minimum or maximum value is either how low if it's a minimum or how high if it's a maximum does this parabola go. How low does this parabola go? It went up 4, yes. So my parabola is normally at 0, 0, went up 4. So now the lowest spot it goes is 4. Now, I'm going to write this as k equals 4, indicating that your minimum or maximum value is always just the y value of your vertex. Again, it's not a coincidence. It's always going to be that way. I don't know if this is going to get too confusing, but okay. That's always going to be the 4. That's always going to be your y value. You just have to decide is a min or a max. Okay. Next thing, domain. What's the domain of this parabola that opens up?
All real numbers.
All real numbers, yes. It's a parabola. It's getting wider and wider and wider. So you can either say negative infinity to positive infinity, or you can say all real numbers. It wouldn't surprise me if in Savas you picked all real numbers. But maybe you enter an interval. I don't remember. So that's always your domain today. Now, okay, range. Domain is left and right. Range is up and down. What's the lowest my parabola goes?
4.
And how do we know the lowest spot is 4?
Is the minimum.
Because it's a minimum, yes? So my parabola is a right side up parabola. The minimum right here is 4. So it goes 4. How high does my parabola go? It's going infinitely up, yes? So my range is 4 to infinity. Infinity always use parentheses. What about the 4? Are we going to touch the 4? Does my parabola go through the vertex at 4? It does. So we're going to use a bracket. Now, I have written in my notes or y greater than or equal to 4. Really am kicking myself for not getting in Sophos to remember which way they want it. Okay? Watch your directions in Sophos. They'll tell you, yes? They'll tell you either we want the interval notation or we want inequality. Okay? But because it's range, we use y. It's all numbers bigger than 4. Now, another connection here, folks. The y value in the vertex is 4. That's my minimum value, and what else is it? That's also the value in the range. Okay? Every time. Okay, questions on that one? Think we can handle that?
That's not light work.
That was light work? I think I'll put it in the doable category. How's that? There's some stuff I feel like you guys are going to throw in the, ooh, I'm not sure that's doable. I'm going to say everything's doable, but this one I think definitely goes in your guys' doable category. Okay? Okay, let's try another one. Same deal. 5 parts. Vertex, axis of symmetry, max, min, domain, and range. So I'm going to do similar to what I did last time. I'm setting it up. F of x equals a times x minus h squared plus k. Our given equation this time is f of x equals negative of x plus 4 squared minus 5. And we're going to start with vertex. Get caught up in what you're writing. You got a vertex for me, Dan, yet? Is it 4, negative 5? Almost.
Negative 4, negative 5.
Negative 4, negative 5. Okay, so this is where, and this is what's going to get us every time, is this one little sign. Keep in mind, our vertex is HK. So this minus, since it's minus H, you have to always use the opposite of the H sign there. Or think of it this way. What would this plus 4 tell us to do on the graph? The plus 4 in the parentheses is going to tell us to go left 4. And so that's how I know to use the opposite sign there. That's the best suggestion I have to remember that. Okay? And then the negative 5, you do use that sign. Okay, so just kind of remember, this is what I'm going to write down to remember. This is left 4. And then obviously the minus 5 is down 5. Opposite sign of the H value. Okay? So, vertex is negative 4, negative 5. Axis of symmetry.
X equals negative 4.
Okay. It's always x equals the x value, right? So x equals negative 4. Always the first number from the vertex. Okay, next. I need a minimum or maximum, and we'll have to talk value. She says maximum. Do we agree?
Yeah.
Now, besides the fact the last one was a minimum, so it makes sense that Mrs. Sargent's going to give a maximum this time, what's the real reason that this is a maximum? Yeah. This number out front, my A value out front is negative. When it is negative, what's that tell my parabola? My parabola will open down. Okay? So because there's a negative, my parabola will open down. And that means my vertex is at the top and a max. You guys can write as much or as little as you want of that, what I have over in the corner there. I'm writing it out just because if you need reminders when you get to looking at notes later. So this vertex is a maximum. Now, again, you pick min or max, but then we need to know what is that value. So this question, since we said maximum, what's the highest point our parabola goes? Keep in mind, our parabola is upside down, yes? So how high does that vertex go? More like how low does it go in a way, but yeah. The height of this vertex is -5. So it's always the k value, okay, or it's always the y value every time. Okay, that will always be your max or min value. You just have to know if it's a max or a min. Okay, what do we do after that? Domain? What's the domain of a parabola that faces down? All real numbers. So, negative infinity to positive infinity, or all real numbers. Okay. Range. Now think carefully here. Range, we're starting where? We're starting down. So hold on. We're going to start down. And then we're going to go however high we go here, right? Keep in mind that what's my parabola doing? It's upside down, yeah? Do you want to give it a try, Danielle? Uh-huh. Mm-hmm. Yep. So this parabola, it's upside down. It's going infinitely down, right? We can all agree there. And then how high are we going? To that max value. What was our max value? -5. So negative infinity to -5. Infinities always have parentheses, and as it was stated, the bracket of the bracket on -5. Again, folks, that's not a coincidence that that value is the same all three times. It's never going to be a coincidence there. Okay. Now, in terms of range, I can tell you, if your parabola opens up, your range will always have this setting here where it was the number to infinity. If your parabola opens up, it's always going to be that idea. If your parabola opens down, it's always going to be negative infinity to whatever y value of your vertex. Always going to have that same format. You just have to fill in the number. Okay, questions here? Okay. Let's move on to the last page of notes. We've been given the equations up until this point, and we've been trying to dissect them, right? We've been using them to graph how far left and right does it go, what kind of stretch, compression. We use them to figure out all these details, right? Well, now they're going to give me some details, and then we have to write the equation, okay? Our job is to write an equation. Now, we're going to use that same form. Normally it says f of x equals. I'm going to write it with y, because you guys know f of x and y are interchangeable, right? So y equals a times x minus h squared plus k. That's the form we're trying to hit, right? And as we look at that, what are we going to have to know? We're going to have to be able to fill in A, H, and K. Those are the pieces of information you have to be able to get from whatever they tell us. Now, what do they tell us? They tell us that this graph has a vertex at 1, -4, and it passes through the point -2, -1. Well, I would argue out of A, H, and K, 2 of them are very easy and staring right at me. What do we already know?
H is 1 and K is -4.
H is 1 and K is -4 because what is the vertex? The vertex is HK. So those values right there, we already have filled in. So when I go to write out this equation, I know y equals, okay, I don't know A yet, but I know x minus h, so x minus 1 squared plus k. Well, you could say plus -4, but what am I really going to write that as? We're going to write it as -4. Now, what's the issue? I don't know A, do I? Okay. They don't give me A either. A is the one thing we have to find. So, they gave me HK, yes? And we know for some reason they gave us an extra point. I mean, they won't give us, well, they could give us extra information, but they gave us this point for a reason. What's the order in an ordered pair? Just in general, an ordered pair is always XY. So what they gave me here is they gave me an extra XY. Okay? What we can do is we can take the X and the Y and we can fill it in here with H and K, and then we can use that to find the A that we're missing. Does that make sense? Like we already have H and K filled into this equation, right? We can also fill in X and Y. And then the only thing we'll have left to find is A, and we can use that to find A. So right here, what do we know Y is? -1 equals A, because that's what I'm trying to find. What do we know X is? -2 minus H, or -1, quantity squared, plus K, which is -4. Okay? So we used X and Y to fill in this equation. We have an equation that just has A in it now. Can I solve it? Yeah, do some math. Okay? For me, it's my Aunt Sally. She's going to tell me to start in the parentheses, right? You guys are going to say what? PEMDAS? So -1 equals A times, what is -2 minus 1? -3, quantity squared, -4. Next thing I'm going to do is I'm going to do -3 squared. What is -3 squared? 9. Now, what is that 9 attached to? That 9 is being multiplied by the A. So be aware here. Think of this as A times 9, or 9A, and minus the 4. The mistake that some of you will make is you'll want to do 9 minus 4. But you can't do that because the 9 is attached to the A. Keep solving. If it's 9A minus 4, we're going to what? Add 4. -1 plus 4 is 3. If it's 3 equals 9a, how do I solve for a? Divide by 9. And what is a? 3/9, which reduces to 1/3. I get that it's the repeating decimal 0.33333, but Savas isn't going to take that. Okay, they're going to want the fraction form. So now, what can I do with this a is 1/3? Like, take it back to the equation. Because remember, we had to fill in a, h, and k. So, final answer. Y equals, what do we say a is now? 1/3. X minus h, which was x minus 1. Quantity squared plus k, which was minus 4. Okay? That's finding your a, h, and k. H and K are a piece of cake. A, you have to work at. It's doable. I said that again. Okay? I definitely think it's doable. Now, what's going to happen? Some of you are going to forget how to do this come homework time. Okay, but go back to your notes and look, right? Okay. Another one. This time they want us to write an equation of the graph of the graph. But what did they give me in that graph? What are they giving me here?
They gave you the axis.
I'm just guessing right now.
What are they giving me? What do we see here? They gave me some points, yes. One of those is very specific. They gave us H and K, yes. Because H and K are the vertex. Can we see our vertex here? Yeah, which point is our vertex? -2, 3, yes? So that makes -2, 3, H and K, because that is my vertex. What about that other point they gave me? It's just a random xy, but they gave me an xy, didn't they? So they gave me a vertex, and they gave me another point. Isn't that what they gave me up here on the last problem? A vertex and a point. The last problem, they gave it to me in words. Here, they're making me take it off the graph. Same deal, though, right? Okay, so let's recall. We are filling in the equation. Y equals a times x minus h squared plus k. You have to be able to tell me a, h, and k. What do we already know? We know h and k. We don't know a yet, do we? But if I had to write this equation right now, x minus h, so that's going to be what? X minus -2. What do we know about x minus -2? That's +2. Plus k plus 3. Okay, h and k are the easy part. We have to work for a. What do we do on a?
We put in X and Y.
Yeah, you're going to fill in. We have xy here, and we're going to fill in xy. Okay, so let's work on this. Y. What are we putting in for y? -1 equals a, I don't know. X. What is x? 0. Minus h, that's minus -2, or in other words, plus 2 quantity squared plus k plus 3. Okay. Parentheses, tough work here. What is 0 plus 2? 2. What is 2 squared then? 4. Now, what do we know about that 4? It is attached to what? the A. So this is going to be 4A plus 3, equaling the negative 1 here. Okay? How do I solve for A?
Subtract 3.
It's 4A plus 3. We're going to subtract 3. Negative 1 minus 3 is negative 4 equals 4A, and then divide by 4. And A is, what's negative 4 divided by 4? Negative 1. Okay. Take that back to your equation, right? Now, when we write this, y equals, A is what? Negative 1, and then it's times x plus 2 squared plus 3. I could see Savas balking at this the way I wrote it. I wrote negative 1 in for A. I'm not against that, but what's Savas going to prefer we put in there? Just a negative, yes? Now, are they going to count that wrong? I don't know. I don't know. I'm just guessing. So I'm going to write this as negative, parentheses, x plus 2, parentheses squared, plus 3. And what I'll tell you is that is your best form of the answer. Personally, if you need that negative 1 in there, you put that in there, I'm not counting you wrong. Savas might, so just beware. Savas is more formal than I am. I let you guys get away with stuff that Savas doesn't. So. Okay. So writing equations. It's doable, just don't forget what you're doing. Okay?
Savas wants to put the plus or the double negative?
The plus, definitely. I don't think they'll accept the double negative. I could be wrong on that. I don't know. But I feel like they don't. Okay. If someone, I say, if you have a free answer, you feel like, you have time to check, go for it. But I really don't think they'd let you do minus negative. Okay. One more section. Okay. We're writing an equation again. This one's a little different, though, because they're giving us the transformations. So, this says, let G be a quadratic function whose graph is a translation 2 units right and 5 units down of the graph f of x equals x squared. And then we're being asked to write the resulting graph, g of x. Okay. This kind of goes back to green paper. How do we show things like 2 units right and 5 units down? How do you, how?
X minus 2.
Okay. So 2 units right means we subtract 2 from the x, yes? Okay, so this is just my brain thinking here. So to do 2 units right, I'm going to have to do x minus 2, right? How do I show a 5 units down?
Minus 1.
To show 5 units down, we just do a minus 5 where? At the end, yes? Okay, now, the original one was f of x. They've asked me to call this g of x. Okay. What are we going to write then? And here's the deal, guys. Make it of that form, that form we've been doing of a times x minus h squared plus k. You're making that form, yes? That's what we're doing. Now, did it say anything about A? Didn't say anything about stretch, compression, didn't say anything about reflection. So do we do anything with A? We just assume it's a plain old 1, and we leave it blank like that. Okay? So what am I going to write? What are we thinking here?
X minus 2 parentheses.
Okay? And then?
-5.
Okay. Does that equation tell me to take x squared and move it right 2 and down 5?
Yeah.
Yeah. You're done. That's all. It's just understanding how to write the equation. Okay? It's kind of putting everything together we've done, yes? Questions on that one? That was pretty basic. Okay, let's try another one. Okay, they're asking us to write g again. Okay. Let g be a quadratic function whose graph is a reflection of the graph f of x equals x squared in the x-axis. So notice there's a reflection in the x-axis followed by a translation 1 unit down. Okay, think about your pieces.
It's gonna be a negative.
Okay, because it's a reflection, we're going to have a negative out front, yes? Okay. What else?
It's gonna be
-1.
Okay, it's 1 unit down, so we know we're going to do a -1, right? This is my brain just thinking. Well, I don't know about you guys, but technically we're ready to write this answer. G of x equals negative.
Would it be like x plus 0 or something?
So, trying to debate how. Okay, so if we say x minus 0 or x plus 0. Now, keep in mind, what is x minus 0?
0.
X, right? So do we really even have to have that?
No.
Could we just have x?
Yeah.
Yeah, we could. Okay. Now, what else do we still have to consider? Do we?
Yeah, -1.
Okay. Don't forget the squared. And then down 1 is going to be a -1 outside. Now, there's one other piece I would clean up here. What is unnecessary? Negative is necessary.
Would it be the 1?
X squared.
The parentheses.
Oh.
Is there anything, did anything end up in the parentheses that matters? No. So I would just end up writing this as g of x equals negative x squared minus 1. That would be your best form. Again, me personally, I'm not necessarily counting the others wrong, but I'm trying to give you the best form. Okay? Okay. You have like 5 minutes. You could peek and solve this. Okay. So you have lesson 2.1. It should be listed as due tomorrow. Between today and tomorrow, you need to spend some time on it, please. Okay, get it done, because then we're going to move into 2.2.